Today we're looking at section 12.3, which is the geometric sequence and series section. This will be very, very similar to what we did yesterday in section 12.2 with the arithmetic sequence and series. You'll need your cheat sheet. We have two new formulas that you'll need to add in, and you'll need your graphing calculator as well. I got to show you how to do something on here. All right, so first up we have a definition. A geometric sequence is a sequence whose consecutive terms have a common ratio r. Yesterday we were talking about the arithmetic sequence, and we had a common difference. We subtracted backwards and got a d value. Today we're going to divide backwards, and we're going to get a common ratio. So again, remember to divide backwards. So these first couple, we want to see if it's geometric or not, and if so, can we find the r value? 6 divided by 2 is 3. 18 divided by 6, 54 divided by 18. We do get the correct value. Common ratio is 3 every single time. In this next one, 7 divided by 2, 3.5, but 12 divided by 7, not the same thing. 1.7 or something. So this one, no, it is not geometric. This one would be yes, geometric. The first formula for today is the explicit formula for the geometric sequence. This formula you need to get in your notes and in your cheat sheet. A sub n is equal to the first term times your common ratio raised to the n minus 1. In the arithmetic sequence, we had to go backwards to find the zero term. If you can remember your equation for arithmetic, a sub n equals dn plus a sub 0. We had to go backwards to try to find that zero term. We don't have to do that this time. We are going to use the first term that we see in the list. That first term, in this first case, will be 4. We're going to use that, and then we have to try to find the ratio. 20 divided by 4, 100 divided by 20. Common ratio is 5 each time. Our explicit formula will be a sub n equals, first term is 4, times by common ratio is 5, raised to the n minus 1. Every single time you write an equation, it will say raised to the n minus 1 on it. And then you could go ahead and find any other obscure number in your list someplace. So say, for instance, you wanted the 10th term, 4 times 5 raised to the 10 minus 1. And then you would just punch in your calculator 4 times 5 to the 9th, and you would come up with your answer. Now these are going to be all exponential, which means they take off in a hurry. Your answers are going to get very large very quickly. So don't be surprised if you get very large answers for some of these numbers down the line in your sequence. All right, number 4 here, negative 12 divided by 36. 4 divided by negative 12. We get negative 1/3 each time for a common ratio. Our equation will be a sub n equals, first term is 36. Common ratio is negative 1/3 raised to the n minus 1. If we are given one term and the common ratio, we're going to go backwards just like we did with the arithmetic sequence. We're going to plug in everything that they give us. Again, I'll start with the formula so we know where everything is going to go. A sub n equals a1 times common ratio to the n minus 1. In this particular example, we've got a sub 5 equals 54. That represents the answer of what we're looking for. That's the a sub n term. 54 equals. A sub 1 we do not know. That is the number that we need to solve for each time. Common ratio in this case right here is 3. And then raised to the n minus 1. N is what term we're on. That's that value right there. We're on the 5th term, so we're going to raise this to the 5 minus 1, raised to the 4th. 54 equals a sub 1 times 3 to the 4th. 3 to the 4th is 81, and when we divide, a sub 1 equals 54 over 81. 54 over 81 is going to reduce. A sub 1 is 2/3. And then we can go ahead and write the model. A sub n is equal to first term 2/3 times common ratio, which we said was 3, given 3 to the n minus 1. Here's another quick example we'll try. A sub 4 equals 12, and the common ratio is 2. Again, here's our notation. The value is 12. We don't know A1. Common ratio is 2, and it's raised to the 4 minus 1. 12 equals first term times 2 to the third. 12 equals A1 times 8. 12 over 8 equals A1. That will also reduce 1 1/2. And now we're able to write our formula. A sub n equals first term, 1.5, times common ratio of 2, raised to the n minus 1. If you have two random points, we did samples like this with the arithmetic. We set them up as two ordered pairs, and remember arithmetic is in the form of a straight line. So we could calculate our slope, and our slope was the same thing as the common d term. You cannot do that when you're dealing with geometric. Remember, a geometric sequence is one that takes off in a hurry, so it's going to mimic what an exponential growth curve will look like. We cannot calculate slope to try to figure out a common ratio term. So we have a set of steps that we need to go through to try to find that common ratio, and then our a term. This is very, very similar to what we did with the exponential models when we had two random points in the curve. First thing we're going to do is pick one of these ordered pairs and solve for a1. Second step is to use the second point, and we're going to back substitute in what we just found for a1 from the first step. We're able to solve for r in that case, and then once we get an answer for r, then we start all the back substituting. Okay, so on the next slide, we're going to see these numbers again. A sub 3 equals 45, and the fifth term is 405. All right, so we're going to start by picking one of the first terms. So I always just like to go in order. First term, a sub 3 equals 45. And remember, here's our model. Again, a sub n equals a1 times r to the n minus 1. The more you write that equation down, the easier it's going to be for you to remember. All right, so the value of our answer is 45. We don't know the first term. We also don't know the common ratio, but I do know what term I'm on. I'm on the third term, so it's 3 minus 1, which is r squared. 45 equals a1 times r to the second. I need to solve for a1. a1 equals 45 over r squared. Now I move to the second term, second point. 405 equals a1. Well, we just got an answer for a1. We're going to use that. 45 over r squared times r raised to the, I'm now on the fifth term, so it's 5 minus 1, which is 4. Now you notice that we've got things that we can start to cancel. R squared goes into r to the fourth, r squared times. So I now have 405 equals 45 times r squared. Divide by 45, 9 equals r squared, and r equals 3. Here's one of those cases again where we are not going to use plus and minus when we square root both sides. We're just going to be taking the positive value of 3. So our r value, common ratio value, is 3. So we're very close with our answer now. We're going to take our 3, put it back over here where we have r. A sub 1 is equal to 45 over r squared, 3 squared, 45 over 9. My first term is 5. And now I can officially write the model. A sub n is equal to my first term, which we just got was 5. Common ratio was 3 to the n minus 1. All right, let's try that real quick with one more question. A sub 2 equals negative 12. A sub 4 equals negative 3. Negative 12 equals first term times common ratio, I don't know that, raised to the, what term am I on? I'm on the second term, so it's 2 minus 1, which is 1. A1 equals negative 12 over r. Okay, now we're going to use the second point. Negative 3 is equal to a1, which we just got, negative 12 over r, times common ratio raised to the 4 minus 1, which is 3. Now I want to start to reduce. R to the first, r to the third gives me r squared. Negative 3 equals negative 12 times r squared. Let's divide out the negative 12. I get 3 over 12, which is 1/4, equals r squared. And now when I square root both sides, r equals 1/2. Now let's take that 1/2 and back substitute. Negative 12 over 1/2. Dividing by a fraction, same as multiplying by the reciprocal. I get negative 12 times 2, negative 24. That's my answer for a sub 1. And now I can write the model. A sub n equals first term, negative 24, times my common ratio is 1/2 raised to the n minus 1. The other equation that we need to look at in this particular section is the equation for your geometric sum. This is the series that we're looking for geometric. So this is actually formula number 4. Arithmetic sequence was the first, arithmetic series was the second. Geometric sequence is the third, and now our geometric sum is the fourth one. This, remember, is called summation notation. It's also called sigma notation. Just like in our arithmetic sequence and series, when we look at it in summation notation, we have to have a start value on the bottom, and a number will be up here on the top. How many terms are we adding together? And then written here is your explicit formula. A sub 1 times common ratio raised to the n minus 1. The way we solve a geometric sum is this format right here. We need to take the first term times big parenthesis 1 minus the common ratio raised to the n over 1 minus common ratio. 1 minus r to the n over 1 minus r. And then sitting out in front will be your first term. Everything that you need to solve this equation is visible right here in this formula. Your first term is the number that's going to go right there. And your common ratio will go twice, here and here. And the n term that we're looking at is the value that's right here. This n term is going to be this n term right here. So everything you need in your formula is visible in your summation notation. All right, let's try to do this one. What is the sum of the first 6 terms according to the rule? 4 times 3/2 raised to the n minus 1. Now again, I'm going to write the formula for us. First term, 1 minus r to the n over 1 minus r. And now we just need to put everything in its place. First term is 4. Big parenthesis, 1 minus common ratio. My common ratio is right here, 3/2. It'll be easier to write it in as a decimal when we use our calculator. 1 minus 1.5 raised to the n. We're adding 6 terms, so it's 1.5 raised to the 6th over 1 minus common ratio 1.5. Now, a lot of people have a hard time with their calculators on this, so my suggestion to you would be to plug this in your calculator going from the inside out. We're going to do the top piece first, get an answer, divide by the denominator, 1 minus 1.5, get an answer, and then times by 4. Okay, so I have a calculator here. Let's go ahead and try this. So inside the parentheses first, we're going to do 1 minus 1.5 raised to the 6th power. Equals. Divided by parenthesis 1 minus 1.5, close your parenthesis, hit equals, and then times by 4. Equals. Answer is 83.125. So if you want to do that when you're doing your summation notation questions, if you want to remember to do that from the inside out, working from the top down. So again, we did this part first, 1 minus 1.5 raised to the 6th equals. Then divide by the quantity of 1 minus 1.5 equals, and then times by 4. Hopefully that should get you the correct answers every time. Okay, so here's the 4 formulas that we've done so far. Can you fill this in without peeking back at your notes? See if you can do it. What's your arithmetic sequence? Arithmetic series, geometric sequence from today, geometric series from today. 4 formulas. We'll get our 5th formula when we talk about the infinite geometric series. All right, that's it for today.